All I wanted to do was upgrade the lights in my shop to make my video look better, but it did not go smoothly. Nothing around here ever goes smoothly. The old lights are visible in the shot, aren't they? Welcome back to Cloud 42. I'm James. When people ask me what kind of camera they should get for recording YouTube videos, I always tell them the same thing. You don't necessarily need a fancy camera to get good results, but you do need a good microphone and you need light. Lots and lots of light. These are the existing lights in my shop. This is what I have been filming under for many years. These are inexpensive, well, relatively inexpensive LED shop light fixtures that I picked up at Costco. These are 4,000 Kelvin color temperature, but they are a fairly low color rendering index. I think they're under 80 or they're spec'd around 80. So anything that's red is always going to look a little bit weird. Skin tones are going to look a little pale, a little green. And that's just something that I've lived with since I've had these. They do put out plenty of light, and that has resulted in some pretty good quality video. There's another problem though, besides just the color quality, and that is the flicker. Because these are LEDs and because we're running on 60 hertz power, they flicker off 120 times a second. You can't see that with the naked eye, but depending on the camera settings and exactly what I'm doing with the footage, sometimes the camera can see that. Now I've got 18 of these in my shop, and that ends up being, for a 3-car garage, just about the right amount of light that I want for filming. I bought these at Costco for I think $30 a piece. I think they were in a 2-pack for $60, and that's how I bought most of them. But lately Costco doesn't carry them anymore, so I've had to go to other sources as I've filled out or needed them in other locations. And I think these are up to $50 or $60 a piece. So they're no longer the cheap and cheerful solution that they used to be. These just hang from the ceiling. They come with, chains and little clips for hanging them. And I've got them hanging down 6-8 inches from the ceiling, something like that. And that's worked okay. But the flicker of these things has really, really started to bother me. And I really want to do something about that. It's not a problem if I'm just shooting stuff at 30 frames a second or 24 frames a second, but it does start to become a problem if I want to do anything fast or slow. Let me show you an example of what I mean. If you look at this footage, you can see gray banding moving up the image. That banding is because the 23.976 frame rate of the camera doesn't sync perfectly with the 120 hertz flicker of the lights. And the result, if I speed the footage up or slow it down, is this banding that you can see. At normal speed, you really can't see it. But when I speed things up like this, it is totally obvious, especially if I have lots of bright whites in the frame. The other place where this becomes a problem is if I want to make invisible edits. So in this piece of footage right here, I have stepped back out of the frame. I'll reach in, move something, and I'll step back and regroup and think about what I'm going to do next. And I'm not moving anything in the frame, so it should be easy for me to edit around this. And then I'll reach back in and do the next thing that I want to do. But if I cut sections out like I'm doing right here, you can see the transitions. Because that banding is there, you don't see it moving normally, but you definitely see it when I make a cut. So this is a case where I'm trying to get continuous flow, even though I'm taking a break to think about something or go pick up a tool. I want to edit that out. And you can see here where I'm making the cuts rapidly, you can definitely see the changes in those gray bars. Now, if you're sensitive to flashing lights, now would be a really good time to look away. This is slow motion footage shot at 960 frames per second, and you can very clearly see the flickering. So the lights are flickering off and back on 120 times a second. And when I shoot at a high frame rate, which I have been trying to do in some videos recently, this is the result. And this is just simply not going to be workable at all. And there really is no solution for this except to get some flicker-free lights. So I bought some flicker-free lights. These ones are from Waveform Lighting. They are not sponsoring this. They don't know I'm making this video. I bought these with my own money and paid full price. These are their 95 CRI LED shop light fixtures. These ones are 4,000 Kelvin. I just decided to stay with the same color temperature I had been using. I don't think it really matters that much, but I've got stuff set up for this, and I have some other lights that are also 4000 Kelvin, so I figured that would be the best choice here. Now, these are not cheap. They're like $100 a piece or 6 for $500. Compared to inexpensive shop lighting, that's pretty expensive, though they're not that much more expensive than those other LED fixtures I've been using. Compared to professional video lighting for a studio, these are dirt cheap. They are packed pretty well, which is good because they ship them. You can see they're linkable. There's an outlet there in one end, and the other end has a power cord with a little pull chain. So just typical shop light stuff. These ones are grounded. The ones that I have in the shop now are not. So, I mean, that's nice. It doesn't mean I can't link them together. I'll have to swap them all out, but I do like that. Now, these ones have LED strips in them instead of, like tubes with diffusion. So the individual chips are exposed. I'm not sure how I feel about that. You can read all the stuff on the panel here and tell me all about ETL and Intertech and how awful they are. It does say conforms to UL standard, but of course this would have been tested by Intertech. So I don't know exactly what that means. They do seem to be pretty well built, though I'm certainly not an expert in evaluating that. You can get a better look of exactly what these are. These are just their LED strips, and they sell these strips in a lot of different fixtures, including just the bare strips and also the T8 bulbs with these strips in them with some diffusion, which, might be a better choice if you already have fixtures. It makes me a little bit nervous that these individual chips are exposed. I mean, there's a sheet of plastic over it, but with no diffusion, I'm a little bit concerned that these are going to be too harsh, but if I need diffusion, it's something that I can add. These are welded closed at one end. Those look like little spot welds to me. And at the other end, they are riveted. I would love to pop these open and see what the power supplies look like, but I really don't want to destroy a $100 lamp just because I'm curious. Well, I mean, I do, but I'm not going to, at least not in this video. If I put the two lights side by side, the new one and the old one, the immediate thing that I notice is that the white paint is a completely different color of white. That's interesting. They're about the same length. The new ones are quite a bit more compact. Now, both of these are intended to be hung with chains, or at least the new ones are intended to be hung with chains, and they come with chains and hooks and a couple of locations where you can put those hooks in. Now, the old ones have some slots, but they also come with these little wire clips. Those go in, and then they have chains so you can hang them down from the ceiling beyond that. But the mounting locations inconveniently are a different distance apart, so I would have to have this chain out at a really extreme angle if I wanted to use the same hanging hooks, so I don't really want that. I also want these things flush to the ceiling so I can get a little bit more headroom in the shop, so I think I'm going to have to come up with something else. Now, you note that the old ones here do have keyhole slots so they can go in the ceilings. These new lights do not have any such thing. They are hanging chains only, and there is no access from the other side, even if I wanted to put a screw through the back panel. So we're going to have to come up with another solution. I've got a little sketch here on my tablet, and I will take some dimensions off of the light, and then we'll be able to take this into the computer, model it, and design a solution for hanging it. Now, lots of the dimensions on these lights are really easy to get, but dimensions like this one between these two little sheet metal folds are a little bit harder. Some of the vertical stuff is easy using the step jaws, but I'll just collect all the dimensions that I can and get a fully dimensioned sketch here that will then allow me to recreate it in the computer and design around it. Because this is sheet metal and because it is folded, it's not super precise, so I'm going to have to allow for a little bit of slop in this anyway. So even just some tail measurements with height off of a wooden surface ought to be good enough. I think that's all the dimensions we need. I'll just take this in, put it in the computer, and yeah, I know they don't add up. This is overspecified, but I just took the measurements I could get. They're not super precise, and it'll be good enough. With my digital napkin sketch and the dimensions that I took out in the shop, I just brought this into Fusion and created the same sketch mirrored around the center line. Hit E for extrude and extruded that out the length of the lamp housing. So this gives us a digital model of the shop light that we can design around. What I want is some kind of clip that will mount to the ceiling with a single screw and that will grip around this light and make it really easy to mount and unmount. And this is what I came up with. I just sketched out a couple of arms that will clip around the lower corners of the light, a little bit of clearance on top here to give it room to fit in, and then some structure on top so that it will rigidly attach to the ceiling and won't have too much flex. Extrude that out, and we have a clip. Now, there's a few things to note about this. One is that I designed this cross arm here to be a flexure. It's got a little bump in it that was mapped out with a couple of circles in the sketch, and the purpose of that is to put some pressure on the top of the lamp and keep it in the hooks. Now, when this flexes upward, it will cause rotation at these two junction points on the outside. So when this presses up, it should press the arm in. And conversely, when the arm presses out from pressure against the housing here, it should press that spring down. And there should be enough flexibility here that this will flex up as I clip it on, and then once it snaps into position, it should hold it firmly in place. Should be easy to clip in and out, but it should still have enough flexibility to make it easy to get in and out, but still held securely. One thing to note down here is that I did design these arms so there is a little bit of interference with the corners of the lamp housing. Now, this is a folded sheet metal part, so it doesn't really come to a sharp like that, but this outside dimension is what I measured in the shop. So in order for these arms to fit, they're going to have to flex outward a little bit, and that'll give it a firm grip, where if it was just designed to fit on the outside edge there would be no pressure. So this will give it a little bit of pressure, and then that'll cause this spring on top to come into play and press down on the lamp, and hopefully the whole thing will clip in and work. Now, I did design a couple other versions of this. I did a low profile mount and a medium profile mount, because I have some places in the shop where the light needs to hang down below some unistrut on the ceiling, and that's what the large version of this is. I have some places in the shop where the lamps can go flat against the ceiling, and I have some places where they just need to clear an air hose. So I've got a 30mm version that will just clear that, but wouldn't be enough to clear the unistrut. The idea is I want all of these lights as close to the ceiling as possible to give me as much headroom. I've got a relatively low ceiling in my shop, but I do need to clear some things. All of these are designed so that they can be mounted with a single screw. So there's a countersunk screw hole here and clearance in this bottom spring so that I can get a driver in here to run that in. And the idea is that every one of these clips will go into the ceiling with a single drywall screw. I'm not going to bother positioning them where I've got trusses behind that. I'm just going to screw into the drywall. That's how I've had the other lights hung now for years, and they do just fine. And it's a quick and easy way to do it, and it makes it easy to move them around if I need to. As I went through the design process, I actually printed several different iterations. This was the very first one. This was just designed to fit on the lamp, and as you can see, it is too loose. It has plenty of space to clip on and fit, and it does hold the lamp securely. It wouldn't fall out of this, but I wanted something that would have a nice snug grip and wouldn't move around very much. You know, if you bump the light, I don't want it to move. I want it to be held securely. I certainly don't want it to rattle if something in the shop is vibrating. The second version has the springs preloaded, and I closed down the headroom a little bit, and I might have gone a little bit too much, because while this does clip on, you have to push it pretty hard, and it's actually distorting the sheet metal of the housing. But then even once you get it pressed on and everything flexes back into position, while it's holding securely, it still has a little bit of a rattle. And so this is the point where I decided I really wanted to have some kind of a flexure in the part so that it would snap on, but then still hold it securely. So this is the first version that has the flexure spring here. And you can see that when that presses up, the arms do indeed flex in. And this is sort of what I was intending. And it's kind of nice to see that actually happening when you imagine something in your head, you design it, you 3D print it, and then actually see it work. That's a good thing. And it does clip on easily, and it holds securely. There is zero motion here. I mean, I can flex it, but the lamp is not moving around in that clip at all. There is no chance that's going to fall out. I really like that, and I think that worked well. I think this is the design that I'm going to go with, at least for the high profile clip. I also have a low profile version here that I printed, and because the flexure is actually shorter in there, because it's supported closer in and isn't as long, I actually made it thinner. So there should be a little bit less pressure on it, but because it's shorter, it might end up being about the same. And so we can try snapping that on, and that actually works great too. For a low profile clip that's going to go right against the ceiling, I think that is going to work. There's enough pressure there that it's snug. There's no motion in it. It's nice and secure. I really like that. Now, of course, I wanted to try a larger one with the thinner flexure just to see if the high profile one worked, just see what that was like. So I've got one printed here with the thinner flexure. It's only 1 millimeter thick instead of 2, and it does flex much more easily. But because it's longer, I don't think that 1 millimeter thickness is enough. I just don't like the way it snaps on compared to the one with the 2 millimeter flexure. Printed in PETG like this, I think the 2 millimeter one is better. The 1 millimeter was a good experiment. I'm glad I tried it because it gives me confidence that the 2 millimeter parameter that I chose is really the right one. So I just need now to print a whole bunch of these. 18 lights times 2 is a lot. The good news is I got lots of 3D printers, so let's go get that done. I have a little bit of a love-hate relationship with the Prusa XL, but for a job like this where I can get most of the 36 clips that I need on a single bed in a single job, it's kind of a no-brainer. I'm printing here with PETG, and the thing that has really improved my results with PETG on this particular printer is a tip that I got from Robert Cowan to go ahead and raise the temperature a little higher than you think it should be. An extra 5 degrees makes the filament flow a little bit better, it makes it retract a little bit more reliably, and it reduces the stringing. It is exactly the opposite of what I expected. I was lowering temperatures to reduce stringing, but it turns out on this printer, if you increase them, then you reduce the blobbing and the buildup of the material on the nozzle because it flows down and sticks to the print better. And it reduces a lot of the problems that I was having. This is pretty passable now. It's not perfect. It's not as good as some of my other printers, but man, if you need a big bed, this is the only game in town. Now, this is a long job that ran overnight, and I actually had a power failure. You're looking at the printer right now after it just booted back up. I lost about a minute on the security camera while the power was out, but the printer remembered where it was, warmed everything back up, and then just started printing again and picked up right from where it left off. It didn't purge or anything. It just heated the nozzle back up and kept printing. And it actually did a pretty decent job. I really wasn't sure what was going to happen. It does rehome after it does that. We missed that because the camera was actually rebooting from the power failure. But this did a pretty good job. I wasn't really intending to test the power fail restart, but I did. It turns out I actually was testing it before and didn't know it because my power cord was loose and it was losing power during the jobs and restarting without my knowledge. And it did such a good job, I never even knew that that was happening. So I do have to hand it to Prusa. You know, they've put their logo everywhere on this machine, but the one that sits in the back below the bed that ends up just above the bed sheet when the print is done, that's pretty classy. They know this thing's going to be out there on social media, and that's clever. I got to hand it to him for that. Well, there's most of the clips I need. I do have to run another small batch on another printer. You can see here the layer line from the power failure. It looks like a layer shift and you can see it, but you can't feel it. So I think that's good enough. I'm actually pretty impressed that that worked as well as it did. With all the clips printed, all I have to do now is take down all the old lights and put up the new ones. I started by making a cardboard template so that I could mark the locations where I wanted the screw holes. Of course, it works a lot better if you actually bring a pencil with you when you climb up the ladder. This is just a flap off of one of the shipping boxes from the new lights. And I made a template and marked the distance apart that I want the clips. I want to line them up with the mounting points on the, that would be used for the chains, just because aesthetically that's what I want to do. Now, I have these mounted in the ceiling with drywall screws through little 3D printed clips. This particular version of the lamp has a couple of cables. Some of them have chains, some of them have little wire bails. They've kind of changed them over the years, but it's just a matter of getting this down and out of the way And then of course, undoing the clips that I have holding all of the wires up out of the way. And then I can just unplug the old lamp and take it away. And I can just throw the hardware on the floor. I will find it later. Mounting the new clips is easy. I started out with a screwdriver, but ultimately switched over to a power driver. I just wanted to be very, very careful because these screws are just going into the drywall. I don't want to strip them out. And with a screwdriver, I can feel exactly what's happening and I can just pull it up snug. And yeah, I got real tired of that real fast because again, with 18 of these to hang, that was taking way too long. The clips on the ceiling, this is the moment of truth, and they just clip right in. I mean, there's just nothing to it. They went right in. They're held nice and securely. You can plug in the chain, turn it on, and we have light. That's one. 17 more to go. This took way longer than I thought it would, but it was kind of nice. My wife came out and did her training. She's got a Women of Iron powerlifting meet here in a couple of weeks, so she's just finishing up her training cycle for that. And it was also nice to have her around because she could hand me things when I'm up on the ladder and didn't bring what I needed, or she saved me some trips up and down the ladder. And that made a process that probably would have taken me 2 days take, the better part of a day to get this job done. It was way more work than I thought it was going to be, but it's done now, and that's good enough. Well, let's do some testing. This is exactly that same shot I did before. This is fast forward at the same speed, and I do not see any banding at all. That looks 100% stable to me. You remember those gray bands were just sliding up the screen in this configuration? Yeah, this is much better. Let's try some quick edits. So I can pull out, edit there, completely invisible. Here's another edit there, and there, 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 there. Yeah, these are just completely invisible. This is really nice. I am going to use this. I've had to do crossfades to try to hide those little bars in the past, but here I'm just cutting at will and you cannot even see it at all. That is just perfect. Let's try the 960 frame per second slow motion. You shouldn't need to look away if you're sensitive to flicker, and sure enough, that is a ton better. This gives a really good idea. I think they claim the flicker is less than 1%. I mean, there's always going to be something because you're running from an AC power supply, but boy, I just don't see anything here at all. I can see some grain from this camera setup, which is something that wasn't really visible before. I'm pretty sure it was there. It just wasn't visible because of the flicker. The flicker's gone, and I can see the difference in the color rendering index. That higher CRI really does make a difference, especially on anything red in the shop. It just pops now where it used to be really dull. However, I hate the lights. I can't live with them. It's difficult to see here, but those individual bare chips are leaving some really harsh, weird shadows, and they're hard to look at. I mean, even just being in the room, those little individual point lights are so bright that even in your peripheral vision, they leave little spots. They leave you see spots after you walk out of the room, and it's just uncomfortable. I can gain the camera way down so you can see them, and you can see those individual spots are shining, and they're even reflecting off of other surfaces. We are definitely going to need some diffusion. I tried several different diffuser concepts here in Fusion. This is the first one that I tried. This is just a thin sheet of plastic material. This will be 3D printed standing on edge, just one layer thick out of transparent material. And it's got kind of a diffusion lens shape similar to what you might see on a commercial fluorescent light diffuser. Just clips onto the sides and has a texture here. Ultimately, I just carved this like I was cutting threads out of the surface of a solid, and then used the shell command to empty out the backside and give it a consistent thickness. I'm not going to bother stepping through that because it takes a while to do, and it also takes a tremendous amount of time to compute something like this. Fusion often gets stuck. In fact, I had to restart Fusion a couple of times to actually get this thing modeled. So I tried this in a couple of different materials. I also created more of a standard flat diffuser. So this is, again, just a piece of plastic that clips on here, intended to be printed in transparent material. And then the bottom here is 1 layer thick. So that'll be a very thin sheet of plastic. It's held off from the surface of the lamp, I don't know, what is this, 25 millimeters, just to give the beams from the LEDs time to spread out, or space to actually spread, so that they hit this in a wider area, so that the glowing area on the bottom will be wider and hopefully create better diffusion. And then I also did a model for just using traditional plastic diffusion material. The idea being that I could just cut a sheet the right width, crease the edges, and tuck them into the lips on the side of the cabinet. And so we'll try that too, see how that goes. I've got some of that material ordered, and we'll try them all and see what happens. I printed some prototypes of the diffusers to test. This first one is printed in white PETG. It's just what was in the printer. Decided to give it a try, and it clips on nicely. It's super, super light. It's only 1 layer thick. If I gain the camera down, you can see that it definitely is diffusing the light, but it also blocks a lot of light. So I think a clear material might be better. So I printed one in clear PETG, and this is 1 layer thick, and the results are really quite clear. I was impressed with how clear that is, but it doesn't really diffuse as much. I'm going to have to gain the camera down even more so you can see it. It's not really spreading the light out. The light is still coming from those 2 narrow strips just over the LEDs. You can see that the diffusion is sort of directional. Across the grain of the print is the direction it spreads. So when it goes on here, it's just really spreading it along the line of LEDs rather than sideways. I tried printing one that's 2 layers thick with a little bit finer texture on the front, and it's slightly better. It's still not amazing. So I decided to try one of the big flat ones. The benefit of the flat diffuser is that the surface prints on the textured print bed, so it has more texture to scatter the light. At least that was my theory. And it actually seems to work pretty well. That's just a single layer of clear PETG, but because the bed surface is textured, it doesn't come out quite as clear. And that's not bad. That's not bad at all. And because it's laying down flat on the bed instead of standing up, it actually prints more efficiently. You can get more of these printed in less time. I can get 3 of these on the bed of the Prusa XL. I need 4 of them per lamp. And that does not look too bad. That looks a lot like a traditional fluorescent light diffuser. It does seem to be spreading it out. I'm not sure how neutral this stuff is. I'm not sure how neutral the color will stay over time, if it'll discolor. It really wasn't intended for this. It's just clear PETG. So I did get my order of real diffusion material. This stuff's made by Lee, a Panavision company. Makes me feel like I'm making movies here in my garage. I got some half white and some full white. We'll start with the half white, and that really does look like about what I want. And you can see that the diffusion, even on this thin sheet material, is way more effective than any of the 3D printed models were. And if I loop it up here a little bit, so I get it a little bit further away from the LED, so the beam has a little bit of chance to diverge and light up a loop of this material, the diffusion effect is really nice. I mean, this is the stuff that they sell for pros, for photography, and for video work. It's no surprise that it actually works. So I think we're going to need to cut some strips of this and try to stuff it into the lamps and see how that works. I really think this is going to give a lot better results than any of the 3D printed solutions. And in fact, it ought to be quicker too, because I can just cut this stuff and I don't have to wait for the printer to print many, many, many large parts. Did I say cutting this stuff was going to be quick? Yeah, that didn't work out. I have some connections in the printing industry, and I thought I could find somebody that had a 4-foot wide paper cutter, but alas, I could not. So it's just going to be giant scissors for me. We'll start with just measuring the length of strips that we need. Mark that with a pencil. This stuff it's a plastic material. It might be a paper material. It's really hard to tell. It's very similar to vellum, but it will mark with a pencil. So I'll just use a carpenter square here, a framing square, and mark this out to length. And this is just a little bit less than 4 feet. It's enough that it will fit between the end caps and tuck in under the lips that hold the lens. Now I took some dimensions off of my CAD model. This is 24 inches wide, and I figured up that I need strips about 6 inches wide. So I'll just measure those out with a ruler and draw some lines down the length of this thing and cut it out with scissors. I do fortunately have a very large pair of scissors, and that made this job a little bit easier. Welcome to Arts and Crafts with James. One little trick here, since I'm going to be making many of these, I extended the line slightly over the end line there so that after I cut it off, there will still be 3 little marks on the tab on the end there. So when I make the next section, I'll already have one end marked, and I'll only have to mark the 6-inch wide strips in a couple of places. Did this as carefully as I could. I probably didn't need to be as careful as I was, but this ended up being a slow process. Again, I needed 18 of these, and they needed to be pretty good. If the edges down the side are not straight, then the creases won't be straight. They won't go into the light straight. They'll buckle and do weird things. And this stuff is pretty flexible. Now to crease the edges, I tried a whole bunch of different things, and what worked the best for me is just to roll it over by hand and then just hit it with a rubber roller. You can hear this roller is definitely squeaking. This is really not meant to put pressure on. This is meant for like inking, for block printing. And so, yeah, it is definitely not for this, but it got the job done. You just have to endure a little bit of squeaking. That puts a nice crease in the side. Flip it around and do exactly the same thing again. And then do it again and again and again, 18 times. Installing these turned out to be hard. Getting them tucked in there without dropping this thing on the floor and keeping it all in place, it was a challenge. You can tell how hard it is because I'm sitting there with my mouth open like an idiot. I showed this video to my wife and told her I was embarrassed because I'm just standing there with my mouth open. She said, yeah, that's what you look like when you're concentrating. So I guess I was concentrating. It is what it is. I got one side tucked in, and then it was pretty difficult to do this. This one actually went pretty well. This is the first one I did. I'm using a dental pick here to kind of get a hold of it, get it tucked in, and then use the point of the pick to hold it in while I work it down the length of the light. This one went okay. Some of the later ones I did not go okay, because what kept happening is I would get about halfway down and it would start falling out from the edge I started with, or the far side of it would fall out. And so there were a couple places where I needed to put a tiny piece of clear tape to hold it in place. In general, this stuff will stay in place once you get it in there, but it definitely takes some work to tuck it in. In retrospect, I should have done this with the light sitting face up on the bench and then anchored the material in place, and I would have been much, much, much better off. I did get them all in, but one of the things that I discovered is that anywhere where this is subject to drafts, like the one that's right in front of the mini split air conditioner, where there's air flowing over it continuously, those ones were almost impossible to get in because they would fall out as I just about got them complete. But I think that over time, they were probably not really going to stay in anyway. That one's in, but I decided that I needed something to retain them, so I 3D printed these end caps. These are designed with a little groove. There's some slop in there because these pieces were not all creased exactly the same, but they clip onto the end of the light, and then they have a groove that the end of the diffusion material fits into. Some of them slid right on. Some of them required a little bit of help from the dental pick. But once they're in, they keep the ends of the little folded tabs from sliding out. And just having it anchored on both ends was enough to pretty much keep these things secured. They move around a little bit, but I really don't think they're going to fall out. I think this is a pretty good solution, and it dresses it up nicely. It actually looks like a professional job and not like I just cut a bunch of diffusion and stuffed it into some slots in the side of some lights. I can live with that. Of course, I have to print 36 of them. And here's the finished product. Well, technically this isn't the finished product. This is the almost finished product. I still need to put the end caps on all of these fixtures. They are currently on the printer upstairs, and when those are done, I'll snap those on, and then this will be truly finished. I like how this looks. I like the extra headroom. I like the light quality. I like the color. I like the lack of flicker, and with the diffusion on there, I'm liking the quality of the shadows that I'm getting. I mean, some of these things, like the garage door hardware, are never going to be great, but that's not really what I'm showing in the video. If you look at the far wall there above the garage door, you can see that the light is pretty diffuse. There are no hard edges there below the fixtures. If we compare that to the same lights before the diffusion went on, you can see that there are hard shadows, and you can see the lines projecting out from those shop lights. Now, I'm not going to be shooting video of the wall above my garage door, but that's just an indication of how even or uneven the lighting is down where I am working, and the quality of the shadows that these things cast down where I actually am working and am filming. And the best thing about the diffusion is that all of those little stars and all those little spots I was seeing in my peripheral vision, those are gone, and it is much, much more comfortable to be in the shop. I thought this was going to be a really simple project. Just take the old lights down and put the new lights up. Not only did the actual process of swapping out the lights and the hanging hardware take way longer than I thought it would, regrouping once I discovered I needed diffusion took up a lot more time. Now, I'm definitely happy to be free of the flicker, and I think I'm happy with the colors. What do you think? Is this better than before? If I put them side by side, can you tell the difference? I can't really tell, of course, from here inside the video. I'll have to play it back later and see, but I choose to believe it's better, especially after all the work I put into it. Confirmation bias is a beautiful thing, and plus I really don't want to take the lights down and return them if it's not. If you enjoyed this, give the video a thumbs up, feel free to subscribe, and maybe think about supporting the channel over on Patreon. The printable files for this and all of my other projects are available there. Thank you for watching.